Hello everyone, welcome to VCIP training course. We have learned a lot about Internet, voice service, and troubleshooting knowledge in the previous few lessons. Today, I will lecture IPTV service and troubleshooting. Through today's course, the goal is to further understand multicast knowledge and master certain troubleshooting ideas for multicast problems. In daily use, can check and try to find the direction of the problem on their own. Now start today's course. The course is divided into 3 parts. First part, IGMP services. This part we will introduce what is multicast, how to configure multicast in VSOL OLT. Second part, CATV. This part will introduce what is CATV and how to control CATV via ONU Web and OLT, including some third-party OLT control. And the last to introduce some case troubleshooting, to show what can be checked when face some multicast issue or CATV issue. Let's start the lecture. The first part, IGMP service. In this chapter, I mainly introduce some multicast basic information and the IGMP service configure in VSOL OLT and ONU. Before introducing how to configure the OLT, I first introduce some basic knowledge about multicast. First, let's take a look at how unicast, broadcast, and multicast work. We can learn from this network topology. In unicast mode, multiple copies of the same information flow exist on the network. In broadcast mode, bandwidth is wasted. Users who do not need this information will also be affected. In addition, routing loops may cause severe broadcast storms. In multicast mode, a single data stream is sent to a group of users at the same time. Each link has only one copy of the same multicast data stream. Compared with the unicast mode, the multicast mode does not significantly increase the network load when the number of users increases. This reduces the load on the server and CPU and saves the network bandwidth. Multicast packets can be transmitted across network segments, and users who do not need the packets cannot receive them. Compared with the broadcast mode, the multicast mode can transmit information over a long distance and transmit the information only to the receiver, ensuring information security. Now we learn the basic concepts of multicast. A multicast group is an agreement between the sender and the receiver, similar to a TV channel. A TV station is a multicast source that sends data to a channel. The STB is the receiver host. If the user chooses to watch the program of a channel, it indicates that the host joins a multicast group. Then, the STB displays the program of the TV channel to the user, which means that the host has received the data sent to this multicast group. And this topology is a multicast service scenario. You can see the process of users applying for a program from an ISP. This process involves some multicast-defined parameters. Multicast VLAN, also called MVLA. Upstream devices only need to send a multicast data to devices configured with multicast VLAN. and then the devices copy and distribute it to different user VLAN with the same multicast requirements. Multicast programs, pre-configured programs, and dynamic programs. Multicast upstream port, manually configuring an upstream port and dynamic upstream port. Multicast data will only be forwarded from multicast routing ports. Multicast user, multicast data receiver, the end-user television. The following are several major networking scenarios for multicast. FTTH install ONU at residential or corporate users. The significant technical feature of FTTH is not only providing greater bandwidth, but also enhancing the transparency of the network to data formats, rates, wavelengths, and protocols, relaxing requirements for environmental conditions and power supply, and simplifying maintenance and installation. FTTB similar to FTTH. FTTB is ONU installed in building. The ONU LAN connect to the room. There are disadvantages such as poor management, multiple failure points, and high maintenance costs. And there are also POL campus and education networking scenarios. After the above speech, I believe that everyone has a certain understanding of multicast. Now I will introduce to you the configuration of IGMP service on the OLT. First, introduce EPON configuration. I will introduce the IGMP setting part, but the prerequisite is to configure the unicast service properly. Enable OLT IGMP general query packet function. Keep others being default. You can also change the query source IP and others if you need. Remember that the query source IP is not multicast IP, but it is unicast IP of OLT. The multicast service will be keep only enable general query feature. For the OLT, you need to configure multicast user VLAN. Select the PON port, user VLAN, and group VLAN. IGMP join message, leave message, and query message use user VLAN. IGMP traffic uses group VLAN. If there is no special request, they use the same VLAN ID. After configured multicast user VLAN, the port can receive IGMP join and leave message. Multicast router port can transfer IGMP messages. Configure the uplink port which connects with multicast source as multicast router port. The VLAN ID is group VLAN. Only when setting up correct multicast ports, OLT will forward multicast data. Different configuration parameters for different types of ONU. Generally, HGU uses Bridge 1 for IPTV service. Create a Bridge Mode 1. Choose the correct parameters and fill the correct value. Bind the port. Choose Other as IPTV service mode so that the STB or PC can get IP address from up-layer DHCP server. Remember to click Submit button of Running Config. In some network environment, the ONU work Route 1 for IGMP. Now I will show the different configuration in SFU-ONU of multicast service. In SFU-ONU, to configure port VLAN and multicast VLAN. In usually, ONU port VLAN and multicast VLAN are same VLAN ID. First, configure ONU port VLAN. As a terminal device, ONU port VLAN should be tag mode. Second, configure multicast VLAN and LAN port multicast VLAN strip mode. After you configure the OLT and ONU, you can play the multicast service. When the service is working, the current joined group can be displayed on the OLT multicast member page. This page you can know if the customer IGMP join packet if received by OLT. Only OLT show the group member in the table. This group multicast will work. Now we are learning how to work GPON IGMP service. Same as the EPON configuration. Enable OLT IGMP general query packet function. Keep others being default. You can also change the query source IP and others if you need. Remember that the query source IP is not multicast IP, but it is unicast IP of OLT. The IP address it to send group member query packet. For the OLT, you need to configure multicast user VLAN. Select the PON port, user VLAN, and group VLAN. IGMP join message. Leave message and query message use user VLAN. IGMP traffic uses group VLAN. If there is no special request, they use the same VLAN ID. After configured multicast user VLAN, the port can receive IGMP join and leave message. Multicast router port can transfer IGMP messages. Same as the EPON OLT setting. It need to configure the uplink port which connects with multicast source as multicast router port. The VLAN ID is group VLAN. Only when setting up correct multicast ports, OLT will forward multicast data. Add multicast VLAN. OLT will transfer the IGMP packet in this VLAN. GPON ONU also distinguish HGU and SFU. Generally, HGU uses bridge mode for IPTV service. Create a bridge mode 1. Choose the correct parameters and fill the correct value. Bind the port. Choose Other as IPTV service mode so that the STB or PC can get IP address from up-layer DHCP server. Remember to click Submit button of Running Config. In some network environment, the ONU work route 1 for IGMP. In SFU-ONU to configure port VLAN and multicast VLAN. In usually, ONU port VLAN and multicast VLAN are same VLAN ID. First, configure ONU port VLAN. As a terminal device, ONU port VLAN should be tag mode. Second, Configure multicast VLAN and LAN port multicast VLAN strip mode. After you configure the OLT and ONU, you can play the multicast service. When the service is normal, the current joined group can be displayed on the OLT multicast member page. Same as the EPON OLT. This page list should show the group member. It will work IGMP normal. In generally, we can check the group members on the OLT to see whether the multicast can be grouped on the OLT. If the join group is displayed on the list, it means that the user's join message has been sent to the OLT and received by the OLT. Otherwise, between the ONU and the OLT network is still unavailable. It need to make troubleshooting, we will learn in Part 3. In addition, you can view the current IGMP message statistics through the command line. In command line, it will show more protocol message received status. This command shows the IGMP packet receive by OLT. When clients do not able play IPTV, focus on IGMPv2 report packet. If the client TV play IGMP will send report packet to OLT. CATV is also a way of playing video, different of multicast. It do not need do more setting in OLT or ONU. And CATV and multicast are working in different wavelength. Let's have a brief understanding of the use and history of cable TV. CATV, Community Antenna Television, is a system of delivering television programming to consumers via radio frequency (RF) signals transmitted through coaxial cables, or in more recent systems, light pulses through fiber optic cables. This contrasts with broadcast television, in which the television signal is transmitted over the air by radio waves and received by a television antenna, or satellite television, in which the television signal is transmitted over the air by radio waves from a communications satellite and received by a satellite dish on the roof. FM radio programming, high-speed internet, telephone services, and similar non-television services may also be provided through these cables. Analog television was standard in the 20th century, but since the 2000s, cable systems have been upgraded to digital cable operation. From the topology, CATV signal and Internet service are combined by EDFA and input to the ONU, which outputs to the user equipment through the RF interface. On the webpage of VSOL ONU, it is possible to control the CATV on or off status, and it can be adjusted. The AGC, Automatic Gain Control (AGC), is a circuit that adjusts the gain of a device based on the strength of a received signal. In CATV, AGC is used in optical transmitters, receivers, and set-top boxes to ensure consistent performance and output levels. Both VSOL GPON and EPON OLT has added a button to control the ONU CATV switch. It is beneficial for administrators to remotely switch on and off the ONUC ATV based on the user's payment status. The status of the ONUC ATV switch remains consistent with the OLT configuration and will not change the CATV status due to restarting the ONU or restoring the factory. In addition to being able to control the CATV switch through VSOL OLT, it can also be controlled through OLT from other manufacturers, such as Huawei, ZTE, BDCom, CData, etc. In EPON mode, it is used private OAM to control, as the OAM standard is not defined it. And in GPON OLT, it is defined, so most the GPON OLT is able to control it. On the ONU webpage, you can see the status of the CATV and the basic parameters. In practical applications, we will encounter various multicast and CATV service problems. In this chapter, we mainly share some troubleshooting methods and steps. I hope to learn how to troubleshoot and find the source of problems through this chapter. Now let's start discussing about the first case. Multicast user fails to go online. The situation of the problem is, when the clients order a program, a blank screen is displayed. Nothing is showing on TV. It doesn't work even if switch channels. And when check the group number page, the information about the joined group is not displayed. Multicast services cannot be played normally at all. Now let's analyze the cause. First, the multicast source problem. If the multicast source have some problem, the OLT and ONU will not receive the correct service. The client cannot play any video. 2. The multicast data configuration is incorrect. If the OLT or ONU configuration is incorrect, the service channel will be able to transfer the data. And there is a certain chance that the ONU or STB is faulty. First of all, we need to ensure that the multicast source is normal. So we first connect the multicast input port to the STB to check whether the video can be played normally. Then the STB is connected to the uplink port of the OLT to check whether the OLT can forward multicast services normally. Add an idle GE port as the port user VLAN, connect TV to the GE port directly and check if multicast can be played. At the same time, you can check whether there are group members through the web multicast member page. Check the IGMP member page. The TV switches to different channels. Refresh the page to see if the multicast can be grouped on the OLT. After check source working well, then check the OLT and ONU configuration. First, check OLT port VLAN, check ONU port VLAN or WAN connect. This step is to confirm the unicast service channel working correctly. Second, check OLT multicast configuration. This step is to check if IGMP setting correct, the OLT will transfer the multicast data. Third, ONU, multicast VLAN, and multicast VLAN tag strip. This step is to check ONU setting if ONU permit to transfer to long side, and the multicast date VLAN need to be removed. After sure OLT and ONU configuration correct, can connect an PC to ONU LAN port and ping the multicast server. Normally, ping will be available between IPTV server and client. Check OLT MAC table if show the client MAC and multicast server MAC. And notice if MAC in the correct VLAN. This photo I share show the server MAC from uplink port and the client MAC from client in VLAN 200. Means the service channel can transfer data. If there are no problems with the above checks, then need to set mirror port and capture packets on the OLT. For the screen, set PON port mirror to OLT-GE port. Source port PON, destination port GE12. Connect APC with Wireshark to capture. The connecting PC should install Wireshark software. Running Wireshark. Capture the IGMP packet. Filter condition IGMP. From the capture, selected membership report or join packet can check the packet if there is VLAN. The packet should be done with VLAN. After PON mirror to check IGMP packet, we can mirror GE port to capture. That can know if OLT forward IGMP packet to uplink port. Same as PON port mirror. Set mirror source GE10. Destination port GE14. Connect APC with Wireshark to capture in GE14. Again run Wireshark and check the IGMP packet. Same as mirror PON port, check if can transfer the IGMP report or join packet. And check the packet if with VLAN. If uplink port configure untag VLAN, the join packet should without VLAN. If uplink port configure tag VLAN, the join packet should with VLAN. At the same time, we can change the filter condition UDP and it will show multicast source data. Multicast data is UDP protocol packet. The host sends the multicast data to a corresponding group. And the destination address is the multicast group address. To be known that the destination IP should be 224.0.1.0 to 239.255.255.255, because 224.0.0.0 to 224.0.0.255 is reserved. After check in OLT side, ONU also can be checked if the ONU transfer the IGMP packet. Same as the OLT, ONU need to be enabled the mirror port, then connect APC to LAN port. Run Wireshark and get the capture. Note, the ONU mirror step is introduced in first class. Please refer to the relevant content in the first lesson. At the same time, can check the multicast group situation. Use this command can show IGMP statistics. From the mark, it show none means there isn't any IGMP report or join packet transfer with ONU. And in this screen, it show multicast group address and the client IP address. This means there is a client sent IGMP to the group number and ONU received the packet. Now we can check the mirror-PON to LAN1 packet. And the filter IGMP, check if there is IGMP packet transfer to PON port. And need to notice the packet VLAN, PON packet should be with VLAN ID. Same as the screen, it show VLAN in IGMP report packet. After checking with the above step and not get solution, you can try change a new ONU, ensure the new ONU correct configuration. With same OLT, fiber, STB, and TV, and check again. Change a new STB, replace a new STB with same TV, and check again. Now we analyze the next example. Multicast program is interrupted. The fault symptom. A TV under an ONU. After watching the multicast normally for a few minutes, there is no screen image. And the program can be played again when the program is switched, but it can only be played briefly. Now let's speculate the possible cause. First, maybe the general group query was not received in user, or the VLAN incorrect, or users do not reply IGMP packet. Second, specific group query was not received in user, or the VLAN incorrect, or users do not reply IGMP packet. Let's check according to our conjecture. Firstly, check the OLT configure. Click IGMP Global, check whether the general query packet is enabled. If it is not enabled, the multicast stream will only be kept for a few minutes and then disconnected. So, it should be enabled. And check if fast leave feature is enabled in OLT port. There are multiple users under the OLT and need to close the OLT port fast leave. If fast leave enable, when a user leaves this group, the OLT immediately stops sending multicast data to this port and will not send query packets anymore, causing other users to not be able to play images. This feature should be disabled. After checking the OLT setting, let's capture on ONU side. Same as the mirroring method mentioned above, mirror the ONU TV playing port to another port. And enable Wireshark to capture packets, wait for about 5 minutes. Normally, it will get the general query packet. At the same time, check whether the multicast stream UDP is normal. The screenshot showing is the multicast data. From the packet capture, we can filter out the IGMP packets. Check whether there is a general group query message from the OLT, whether the received multicast message has VLAN. And then see whether the STB replies to the query message, and check the reply message whether to bring VLAN. 1. If the IGMP query packet with VLAN, then need to check ONU1 or port VLAN configuration. 2. If the IGMP reply packet with VLAN, check the STB and replace a new STB. 3. If there isn't IGMP reply packet, replace a new STB. We keep mirror capture, shift the TV video channel. There will have special membership query packet. When a group user leaves, it will send a leave group message. After OLT receiving the leave group message, OLT will send a group-specific query to determine if there are other multicast receivers in this multicast group, and the STB should send report packet for replying. From the packet capture, we can filter out the IGMP packets, check whether a specific group query packet has been received and replied. 1. If the IGMP query packet with VLAN, then need to check ONU1 or port VLAN configuration. 2. If the IGMP reply packet with VLAN, check the STB and replace a new STB. 3. If there is an IGMP reply packet, replace a new STB. Now, we analyze the last phenomenon. Frame freezing occurs in a multicast program. The fault symptom. When users watch multicast TV, there is sometimes experience of freeze phenomenon, which is not smooth. Possible cause. First, the multicast source itself has a freezing problem. Second, optical signal problem. Third, multicast low bandwidth. Fourth, ONU fault or STB fault. Firstly, let's check whether the multicast source is smooth. First, the ISP line connected to user directly to check if multicast is smooth. Second, add an idle GE port as the port user VLAN, connect TV to the GE port directly and check if multicast is smooth. Check optical power on ONU. Log in ONU Web and check the ONU receive optical power. Or use an optical power meter to measure. The ONU received optical power range should be -7 dBm to -28 dBm. If the received optical power is too high or too low, the ONU will lose packets when sending and receiving data. Allocating low bandwidth can lead to packet loss and result in not smooth video. It is necessary to increase the bandwidth appropriately. Check the ONU long port negotiate speed. Normally, it should auto-negotiate 100 Mbps or 1 Gbps full duplex. Finally, replace a new STB or replace new ONU. Now we analyze CATV issue. CATV fuzzy and lag will happen in some field. The fault symptom. A TV connect to ONU CATV port. When playing the video, it is not smooth and suddenly experiences stuttering and screen flickering. The possible cause. The CATV optical power is too strong or too weak. First, log in ONU webpage and check the CATV input power. If you have a power meter, you can measure with wavelength 1550 nm. CATV received optical power range should be -2 dBm to -12 dBm. Some user complain that the ONU CATV is working as expectation, but ONU CATV status change after power reboot. Possible cause. The operator set ONU CATV on or off by OLT. After that, somebody changed the ONU CATV on ONU webpage again. When ONU reboot, the ONU CATV status will synchronize again the OLT setting. First, check the OLT setting of the issue ONU. If not find setting issue, you can collect and analyze the OAM or OMCI log. Please refer to the relevant content in the first lesson. That's all for today, class. Thank you for listening attentively. Please continue to join the following courses. Thank you.